All right, so here's the deal. With inscribed angles, we said the vertex is on the circle, right? And then you would have two chords that are inside the circle somewhere that get you an intercepted arc. Today's lesson is that same idea, except that now you have a tangent instead of two chords. So if this is my circle, now it's going to be a picture that looks something like this instead. So you'll have your line here. We're going to change that color actually. And then you'll have this tangent over here. Okay, so if this is B, and then we're going to put a D here just for naming purposes, and C. If I'm looking for how big angle C is, so I'm looking for this angle, the same rule applies as when we had two chords, right? You're looking for what is the intercepted arc, and you're going to cut it in half. Well, the intercepted arc now actually ends up where your vertex is. So my intercepted arc is BDC. So whatever the measure of this arc is, your angle C will be half of that, okay? So it really is the same thing. It looks slightly different because you have a tangent, but we would say the measure of angle C is equal to half the measure of arc BDC. Okay, so whatever that intercepted arc is, we're cutting it in half. So that can look like this, or let me draw you just a bigger version of that tangent here. It could also be this setup. Okay, so here's the point of tangency. That means this angle is half of, if this is B, D, and C, same formula, right? The measure of the angle, C, is half of arc BDC. So your intercepted arc right now goes from B through D all the way around to C. So whatever the measure of that arc is, you're cutting it in half, and you'll get the measure of angle C, okay? So let me give you a few examples of that. So this is like example 3 in the book, I believe. They're going to tell you AC, line AC is tangent. And then if the measure of arc BED is 214, I want to know what is the measure of angle DBC. And here's your setup. So you have a circle. You have a line that is tangent. Okay, so here's your point of tangency. This is B. This is A and C. This point up here is D, and then we're going to put a point over here that's E. Okay, so think about what they told us. They said that AC is tangent, okay, so we know that bottom line is tangent, and then the measure of arc BED. So BED would be this arc. Okay, they're telling us that arc is 214 degrees. they're asking us, what is the measure of angle DBC? So DBC, that's this angle. Does anyone see a way that you can figure out that angle knowing that opposite arc? Right. Okay, so the whole circle is 360, right? So if this portion of it here is 214, you're going to go 360 minus 214 to get this arc DB. And that comes out to 146. Okay. And then what do we have to do to that? You got to cut it in half. This arc here is twice the angle, right? So you would take half of 146. This came out to 146. So angle DBC would be 73 degrees. Does anyone see a different way you could have done it? Because there is another way you could do it. Sam?
You could cut 214 in half and then 180 minus whatever that is.
Right, so this is a straight line down here. So if we cut this 214 in half, that would be 107 for this angle. And then those two form a straight line, which is 180. So you could have done 180 minus 107 also. It's not like one way is better than the other. It's the exact same amount of steps. It's just whatever you prefer to do first. Okay? Questions on that? All right. Next example, and this is actually our last one. So this is like example 4. You're going to have a tangent over here. A line that cuts through here. Chord and another chord. So this is Q, this is J, L, and K. One key thing to note is they put a center there, which means you have a diameter. Okay, so pay attention when the center is marked, you have a diameter, and that's helpful information for you. They're going to tell us this is 35 degrees. We want to know this angle here, angle Y, and we want to know this angle, which we're going to call X degrees. Okay. What do we know? How can we find what we need? What do you see in this problem? Sam?
Well, 35 is an inscribed angle of arc JL, so you can find what that is. And then, wouldn't the angle just be 35?
The angle's not 35, but you're definitely on the right track. So this angle here, right, has an inscribed, the inscribed angle is 35, which means the intercepted arc is twice that. Okay, so this arc right now, oh, what did you say? Wouldn't the angle just be what?
Just be 35.
Oh, I thought you said 70. Yes, the angle would be 35. This arc is 70, right? Because the angle is 35, you double it. And that arc is the intercepted arc for this angle here as well. So there's a lot of overlap going on. Remember what we said in Thursday's lesson? That if they share the same arc, they are the same angle. Well, these two angles share the same arc. The 35 and the x have the exact same arc, okay? That means that x is half of that 70, or you could just look at the picture and say then it has to be 35. Okay, so x is 35. How do you find y? You have a couple options here for how you can get there. There's not just one way. You gave me the last one. Someone other than Sam. Who's got this? I mean, I appreciate it, Sam. That's great. You want to tell all of us whatever you're about to tell her?
I'll try to tell the answer.
So you do want to tell all of us then. Go for it, because nobody else is jumping in.
Isn't it 180 minus 70 and divide that by 2? Because you have to find the other arc and it's diameter.
Right, so you have this setup, right? Here's a diameter, which means this arc is 180. Okay, if that arc is 180, and we know that this portion of that is 70, right? 180 minus 70 is going to give you an arc of 110. So this arc here is 110. And now if you look at your y opens up to that arc. Y goes here to here. So this would be the intercepted arc for y. So you take that 110 and you cut it in half. So y would be 55 degrees. Does anyone see a different way you could have gotten there?
Angle QJL is 90 degrees.
Right.
So that makes it
Right. So this angle here, QJL, is 90 degrees because it opens up to a diameter or a semicircle. So if that arc is 180, then the angle is 90, right? And then you have 35, 90, and y that are making a triangle. So you could subtract from 180 there as well. Okay? Any questions on that? Okay, here's my biggest concern on a problem like this. There's just a lot of lines everywhere. Don't let the lots of lines throw you off. Just shade it. If you need to shade to see where different arcs go and different angles go, by all means.